So what we're going to end up doing is putting all the knowledge that we already have on logarithms and on inverse properties to be able to solve these equations. So on number one, it's as easy as this. You have log base 5 of something equals log base 5 of something. So yeah, you could show your work. You could do this. You could put a big 5 right here and a big 5 over here and put the equal sign between the 5s now. So what I did was I raised both sides to be the power of base 5. So now I could cancel here, I could cancel here, but the bottom line is the log base 5s disappear. And I have a new equation that reads 4x minus 7 equals x plus 5. And now let's just solve it. Well, I'm going to subtract x on both sides. I want to have a new equation that says 3x minus 7 equals 5. And what do I do next? Add 7 to both sides. If I add 7 to both sides, I'm going to have 3x equals 12. And my final step, I divide by 3 on both sides. So that'll give me a final answer. I want to write it over here on the side. X equals 4. Easy peasy. Let's move on. Number 2. I have 5 to a certain power equals 5 to a certain power. In my head, I'm going to apply a log base 5 to both sides. And what's going to happen? It's going to cancel out. You're going to have a new equation. That new equation is 2x plus 1 equals 7. Now, I don't know. If you want to see your work, go for it. So you could put the log base 5 up there of 5 and the log base 5 of 5 and then show that it cancels, and the 2x plus 1 comes down, the 7 comes down. But honestly, that ends up being a waste of time. So let's just keep going here. You're going to subtract 1. That's going to be 2x equals 6, which means that x equals 3. We're done. Piece of cake. Let's move on to number 3 over here. So this one's a little different. I don't have a log base 4 on both sides of this equation. But I do know how to get rid of a log base 4. How do I get rid of a log base 4? Raise it up to be the power of what? Of 4, that's right. So you're going to put a big giant 4 on this side and also a big giant 4 on this side. What you do to one side, do to the other. And the equal sign is no longer between those two. It's now between the 4s. Does that make sense? I really do have 4 to this power. 4 to this power equals 4 to this power. Now, why did we raise it to be the power of base 4? So that these will cancel out. And our new equation is going to be an equal sign right here, and you're going to have the 5x minus 1 on this side. And you're also going to have 4 to the third on the right side, but I might as well do it. What is 4 to the third? 64. So you see how that complicated logarithmic equation became a simple algebraic equation? Right? Algebra 1 equation. So let's now solve. I'm going to subtract 1, or actually add 1 on both sides. And I will get 5x equals 65, which means that x equals what if I divide by 5? 13. We're done. There's your answer. X equals 13. Let's move on to number 4. Now right here, I have 9 to the 2x power, and I have 27 to the x minus 1 power. Wouldn't it be nice if this 27 was a 9 instead of 27? Then I could just do log base 9 on both sides, right? It'd be nice. But could I actually change 27 to become 9? Not really. So what I need to do is start thinking, well, this 9 and this 27, these guys could both be changed to what? 3. That's right. So I'm going to change this 9 to become a 3 squared, and I'll still have the 2x on the outside as a power. And over here, I'm going to change this 27 to become a 3 to the third, and I still have the x minus 1 on the outside. Now, what do I do when I have a power to a power? Multiply. Power to a power, multiply, right? 2 times 2x, what do I get? 4x. So I really have 3 to the 4x equals, and again, what I do when I have a power to a power? Multiply. Now, the tricky part here is you have 3 times x minus 1. It's a single number times a binomial. So you have to distribute 3 times x and 3 times negative 1. So we know something for sure. We have the base 3. But once we distribute 3 times x, we get 3x as a power. And then 3 times negative 1, you get minus 3 also as a power. Are you guys with me? So what have we done? We've changed the base 9 and the base 27 to become base 3, and now we could apply a log base 3 here and a log base 3 here. You don't even need to show that work because you know it's going to cancel and cancel. So your new equation will be 4x equals 3x minus 3. And we still need to solve this guy. Algebra 1 stuff. What do? Subtract 3 on both sides. And what do I get? I get x equals negative 3, and I'm done. Now, if you missed that, again, we subtracted 3x, and we subtracted 3x, and that's how we got that x down there. So x equals 3 is your final answer on number 4. Let's move on. Number 5. Again, this is all on video, so you could pause it, rewind it, play it again on Edmodo. Number 5. Right here, I have a problem. I see a common log, and I want to get rid of the common log by raising it to be the power of base 10. But the problem is that there's 2 logs on one side of this equation. There's 2 logs on one side of this equation. I can't really do that unless there's only 1 log, right? So what do I need to do? I need to use my previous skills of condensing and put them together as one single log. I want to condense using the product property because there's a plus sign between them. So you're going to have one single log. This log and this log become one single log. And what I need to do is multiply this guy times this guy. You guys remember that? Product property, put them together and multiply. So I might as well show my work here. Check it out. I want to put 2x times x minus 5 inside that logarithm. Okay? So let me distribute 2x times x. So I'm going to have a single log of 2x squared minus 10x. Are you guys with me? I hope so. And I still have the equals 2 over here. So now that I have a single log, now I could get rid of that single log by doing what? Raising both sides of the equation to become powers of what? Base 10. So I'm going to put a big fat 10 right here and a big fat 10 over here. The equal sign is no longer up here, but it's now between the 10s. So I really have 10 to this power equals 10 to the second power. And once again, 10 to the common log, that cancels out, doesn't it? So what do I really have on the left side of my equal sign? I really have a 2x squared minus 10. And on the right side, what do I really have? 10 squared. What's 10 squared? 100. Yeah, I forgot the x on the 10. Thank you very much. I forgot. Yeah, so there's a 10x. I forgot to bring down the x. There it is. So we really have this equation, 2x squared minus 10x equals 100. There are no more logs. Now I could worry about solving it with my Algebra 1 skills. So what do I do to solve? What was that? Okay, I can't hear. Divide everything by 2 to make it a little easier. Sure, why not? Let me divide by 2 here. Let me divide by 2 here and divide by 2 here. So let me rewrite my equation over here to the side. My new equation will be, go up here, it's going to be x squared, it's going to be minus 5x, and it's going to be equals 50. That's an ugly 50. Question? That's exactly what we're going to do. We're going to subtract 50 from both sides, okay? So when we subtract 50 on both sides, we're going to have a new quadratic trinomial equation that's set equal to 0. So you're going to have x squared minus 5x minus 50 equals 0. Now you could use a quadratic formula. I don't recommend it because this is factorable. So if we factor it, what times what is 50 that if I add, or actually what times what is negative 50 that if I add together gives me negative 5. That's negative 10 and 5. Good job. And now that it's factored, now I could split it and solve. Okay? So when I split it, I'm going to have x minus 10 equals 0, x plus 5 equals 0. You're going to have x equals 10 as one answer when you solve it. The other one's going to be x equals negative 5 as the other answer when you solve it. Now, I need to take a moment right here and explain that just because you get two answers doesn't mean that you actually have two answers. You guys remember semester 1 when we had extraneous solutions? An extraneous solution is an answer that you get that's an extra answer that doesn't work. So the question is this: when you get two answers like this, what are you supposed to do? You need to take this one and just for a quick second, make sure that it doesn't mess up anything. 10, if I put the 10 right here, 10 take away 5 is 5, and yeah, I could do the logarithm of 5, that's cool. If I take 10, plug it in right here, it'll be 20, logarithm of 20, yeah, I could do the logarithm of 20. And it's not a nice answer, it's an irrational answer, but you could do it on the calculator. But if you take negative 5 and put it in here, negative 5, you're going to have negative 10 inside parentheses. And if you do common log of negative 10 on a calculator, it's going to say error. It's not going to work. Okay? You cannot get negatives. You can't take the logarithm of a negative number. You just can't do it because it's a domain error. And I'll explain it in class, but I'm not going to explain it on this video. But you just cannot have a negative when you plug it in. If it's negative, you know that that's an extraneous solution. So we just put a line right through that x minus 5. That's what we call an extraneous solution. Okay? So whenever you do get an answer on a logarithmic function, always make sure that you take the answer and you plug it in quickly just to make sure you don't end up with negatives. So right here, the negative 5, yeah, you end up with a negative 10. That messes it up. You can't, it'll say error on the calculator. And that makes this one right here an extraneous solution. I want to continue with these on the next video.